Let's apply Newton's method to a really simple example. Let's say we want to approximate the cube root of 5. So what we're going to do is we're going to write out x equals the cube root of 5, and then I'm going to simplify that equation by cubing both sides. So x cubed equals 5 now, and we want to move everything over to one side of the equation. So let's subtract the 5, and now we have x cubed minus 5 equals 0. And now the x cubed minus 5 we will write down as our function. Let's call it f of x. And we're going to look at the graph from here. We want to get an approximation for the solution or a solution to this equation. So the cube root of 5, let's think about it. If you take 1 cubed, that's 1. If you take 2 cubed, that's 8. That's too big. So it's going to be between 1 and 2. Let's pick 2 for our first approximation. So let's choose x1 equals 2. And when we use the equation that we developed using the tangent line, if we want to get our second approximation, x2, we need to take negative y1 over f prime of x1 plus x1. So we've got, if you plug in 2 into your function f, you get 8 minus 5, that's 3. So x2 is equal to negative 3 over f prime of 2 plus 2. So what's f prime of 2? Well, f prime of x is 3x squared, just using the power rule. So you plug in 2 to that, you get 3 times 4 is 12. So you plug in x equals 2 into that equation, you get x2 equals negative 3 over 12 plus 2. And then we can go and get the third approximation by taking that number that we just got for x2. We would simplify it some first and plug that number in to the next equation. So x3 equals minus the y value at x2 divided by the derivative at x2 plus x2. So you get another number, then you just keep going in this process.